Have you ever wondered what happens when a star dies? Across the universe, stars are born, they shine, and then eventually they come to an end. But every type of star has its own unique death, a final transformation that's as awe-inspiring as the life it lived. Today, we're diving into the different kinds of stars: red dwarfs, brown dwarfs, white dwarfs, red giants, and the mighty supergiants, to uncover what happens in their final moments and what cosmic marvels they leave behind. Let's start with red dwarfs, the smallest, coolest stars in the universe. These stars are like the slow burners of space. Red dwarfs, such as Proxima Centauri, burn their fuel so efficiently that they can live for trillions of years, far longer than the current age of the universe. Because of this, we've never actually seen a red dwarf die. But when they do, it's predicted they'll gradually cool and fade, slowly turning into what's known as a black dwarf. This theoretical remnant would be a cold, dark star, a quiet, almost invisible death, leaving behind only the ghostly memory of a once bright star. Now we move to stars like our own sun, called yellow dwarfs. These medium-sized stars end their lives in a much more dramatic way. After about 10 billion years, a yellow dwarf like the sun exhausts its hydrogen fuel and expands into a red giant. Imagine our sun swelling to hundreds of times its current size, possibly even swallowing nearby planets like Mercury and Venus. In this red giant phase, the star sheds its outer layers into space, creating a spectacular cloud of glowing gas called a planetary nebula. As the nebula expands, the core of the star shrinks into a white dwarf, an Earth-sized remnant that slowly cools over billions of years. Eventually, this white dwarf will fade, leaving only a dark, cold black dwarf, a fitting finale for a star like our sun. Next, we have massive stars, which go out with far more drama than their smaller counterparts. Stars like Betelgeuse, an iconic red supergiant in the Orion constellation, end their lives in some of the universe's most powerful explosions, supernovas. When a red supergiant exhausts its fuel, the core collapses, triggering a mind-blowing release of energy that lights up entire galaxies. This explosion is a supernova, and it flings the star's elements, like carbon, oxygen, and iron, out into the cosmos, seeding space with the ingredients needed to form new stars, planets, and even life itself. After the explosion, if the core that remains is small enough, it becomes a neutron star, an incredibly dense object with gravity so strong that its surface is smoother than anything on Earth. A neutron star is like a cosmic relic, a dense reminder of the star it once was. But when truly massive stars, called hypergiants, reach the end of their lives, their fates are even more extreme. Instead of forming a neutron star, these stars collapse further into something that defies our understanding of physics: a black hole. Imagine an object with gravity so strong that not even light can escape. Hypergiants like the distant star Vi Canis Majoris can end their lives by creating one of these mysterious cosmic giants, transforming into a region of space where time and matter bend. These black holes become cosmic architects, influencing galaxies and pulling anything that comes too close into their depths. And in some cases, the merging of stellar black holes can even create supermassive black holes, which anchor the centers of galaxies, including our own Milky Way. Finally, there's the brown dwarf, a peculiar type of failed star. Brown dwarfs are too small to sustain the nuclear fusion needed to shine as a true star, so they spend their lives as faint, dim objects, never quite living as other stars do. Brown dwarfs cool and fade over time, eventually becoming cold, dark objects. They don't have a dramatic death, but they're fascinating in their own way. They're like stars that never fully made it, drifting through space as quiet wanderers. So, what happens when a star dies? From red dwarfs quietly fading to supergiants exploding in supernovas, every type of star has a unique end that contributes to the endless cycles of the cosmos. Some return their elements to the universe, creating new stars and planets, while others leave behind neutron stars and black holes that continue shaping the universe in powerful ways. Each ending tells a story of cosmic rebirth and transformation. If you found this journey through the lives and deaths of stars as fascinating as we did, be sure to like, subscribe, and join us as we explore more mysteries of the universe. Because in space, every ending is just the beginning of something new.